Why use ELSD? To characterize non-chromophoric compounds and to confirm purity. For one example that we ran into about 30 years ago at Varex, we had a large petroleum company submit a sample to us for purity. And they had a 2-component separation they thought was pure. And they asked us to run it on an ELSD. They had done the test on UV. And they had 2 peaks of interest at 2 minutes and 4-minute retention time and about a 20-minute run time. We ran that same compound on an ELSD, and we found not only were there 2 peaks transposed in regards to response, because the ELSD is mass proportional and non-specific, we also found 2 additional components in their compound. They did not have a pure compound. And their relative percentages were misleading because of the response on the UV detector. Their first peak was actually their major component with low chromophoric properties. Their second peak had high chromophoric properties but had low mass. But we ran it on ELSD, we got a mass proportional response. This is the minor, this is the major, and we found 2 more components in their compound. So their compound percentages were off and the relative purity was off. And once they saw that, they bought a bunch of ELSDs. Some additional examples of why you would need to use ELSD are to analyze lipids, polymers, for example. These are real-world compounds that people are analyzing. These are some of my clients, actually. I have a client in California that's doing lipid analysis. It's a multivesicle and single-vesicle spherical lipid they encapsulate with bupivacaine, which is a Novocaine product. And it's a very amazing product. It's currently on the market. I won't plug them, but they use ELSD to make and manufacture this. And it's a very excellent opioid alternative. But they're analyzing a lipid, which is a non-chromophoric compound they encapsulate the target molecule in. So they need to look for purity of the lipid, the abundance of the lipid, from the raw material stage when they get the raw material to make the lipid to the final product when it's encapsulated. And then they do a thing called stability testing over time. They'll store samples of each production batch and they'll go back every year and retest it to see how stable it is over time. Because a lot of products have a shelf life and they have to test them for stability. And they're still non-chromophoric compounds. My other client in Florida, they're analyzing contact lenses. So they're looking at polymers for contact lenses. It's a non-chromophoric compound. And they are manufacturing and doing quality control and testing raw materials on contact lenses. Another example why ELSDs are excellent. They're excellent silica and turbidity detectors. If your nitrogen gas or your air supply is contaminated, the ELSD is going to see it. So ELSDs will see turbidity, they'll see silica bleed, they'll see dirty air. ELSDs will see everything. They're used to augment mass spectroscopy. So when you use an ELSD, you're going to see things that you may or may not want to see. But that's what they're there for. They're there to help you assure the purity of your compound.